Getting set up for the wiring has actually taken quite a bit of time because I have to order a lot of different wiring harnesses or spools of wire. So I went through and kind of made a list of what components use what gauge wire, if it's a 2 or 4 conductor, that kind of thing. And purchased a bit of stuff here. We've got split loom. The Dilithium battery management system. It's a modular BMS designed for multi-cell lithium battery packs. It's implemented in 2 assemblies, the BMS controller, which is the BMS-C, and the BMS satellite, BMS-S. The controller consists of a processor and measurement board, which can, with 24-cell battery management system. You can add up to 3 satellites connected to the master, resulting in a 48, 72, or 96-cell system. Our Tesla batteries have 6 cells per module, and a battery is a collection of cells, so we have a total of 6 times 7, meaning 42 cells. So that means we have an additional 6. I gotta figure out how to terminate those wires or pair them up. TBD. The BMS creates alerts. It can help figure out low voltage drop or high voltage alert can be set so it stops charging. It also can help with balancing of the battery module so that the charger doesn't just do a general, here's everything. It can, I think, modulate the charging from individual cells so that everything charges evenly. So Masterman, here's the wiring for the thermistors. We have 5 on this side, 5 on this side, another 5, and another 5. 13 wires on each of these plugs. There's a black one. Our diagram is showing that it's not used in some or all of them. And then this little guy here, the small plug has a 2-wire connection to Satellite Man. So all of these diagrams are over at EV West's website. Some of them are found through the main page where it's like the resources. Some of them are found through the items that you purchase, like the Dilithium battery management system has the wiring for this, has this PDF in it. And this is a 2+3 configuration, so 2 batteries in one box, 3 in the other, and that's 5 modules totaling. There's the BMS satellite, there's the main BMS, and it gives you some idea of how to do a 1P5S, which is 1 parallel 5 series battery setup. Because the more I can stay to it the way it's designed here, the easier it'll be for diagnostics, and I don't have to create a custom wiring diagram. But I did create a custom wiring diagram for the batteries. Here's our box in the trunk, the negatives, the positives, and here's the hood. Let's open it up. Voila, you got these conduit tubes that are gonna be underneath the car. They're gonna look like that. It's the hard plastic pipes that we saw previously on that Corvette. So there's like the fiberglass belly pan, and we're looking from the bottom up. And at the rear of the car is the contactor box underneath. Here's a view of it. Very helpful, this one here, because I have some idea of what all the mounting points are supposed to look like. The goal is to pack as much as you can into this contactor box. That'll keep it very efficient, but you also want it to be serviceable because imagine trying to like replace some of the stuff and you have to disconnect a ton of high voltage wiring. That can get a little scary. So anyway, that's all just to say that these are the 2 conduit pipes that are gonna connect from the trunk to underneath the hood. So our box there, this is the contactor box. There she is. We have our 48 volt contactor inside, and the shunt is probably inside. I don't see it here in the photo, but who knows where they put it. From the contactor, in the contactor box, the 48 volt is gonna go into the power switch. The power switch will then go into the positive of battery number 1. Boom. The next couple of connections are all in series, so current flows into the battery, negative to the next positive, to the next negative, to the next positive, and the final negative is gonna come out of here, go down through the conduit, and into the positive of number 1, the negative into the positive, and the negative into the positive, and the negative into the positive. And the final negative is gonna come out of the box and make its way to the shunt, but it has a bit of distance to travel here, into the conduit, out of the conduit, and the negative side of the shunt. That's essentially what this diagram is showing. The manual for the battery management system from July of 2019. This is becoming my new best friend. It's got all the information, and I'm about 6 pages of the way through, so it'll answer many of my questions right here. Dilithium also has a touchscreen display. Look how cool this is. If I could find one of these, I'd be quite happy to install it in the car. It's got a lot of options to check your charge and check your state of charge and the status of a charger. How fun. I've done what any sensible gentleman will do, and I have brought my work home into my bedroom. So I'll walk you through the components as I'm starting to outline the EV system. Naturally, I want to take inspiration from other YouTube videos. Jerry Rig Everything. He has been making an electric Hummer, and it's pretty cool. Another box of EV West has arrived, and let's just walk through the wiring here before we get into this. It used to be scarier, but now it's a little calmer. Okay, first things first, there's this diagram, which EV West has in an earlier setting, and it's your dilithium battery management system, the BMS, has a master and a satellite, and of those, there are LTCs, which is the computer chip that controls it. Each one of those can do up to 12 cells, and we know that there are 6 cells per battery module. But since there's 2 LTCs, they split 6 and 6 with the first 2 modules in this diagram, and they did 12 by doing 6 here, and those go to LTC 3, and then LTC 4 has the final 6, and then you have to terminate the remaining wires into one of the terminals there. And then those end up into the battery box. The issue I was having was here with the master diagram, and that's because the plus and minus going in and out of the boxes was different here than it was in the previous 5 module setup. And I wanted to ask about that. I got a few questions clarified through EV West, but here you can see this is going to be essentially our Bible for the build. This has the brains of the operation here. That is the motor controller. It's going to have the phase leads, which is the 3 wires going into the motor, and it will sit really close by. Make sure these are short. That's going to be water cooled, so we want it to be here with coolant pumps and fans. Then you've got the pedal, which is our Prius pedal, our displays, the charger, the DC converter. Those are sitting up here on the front of my TV stand. You've got the AVC2, which helps to control some of the switching of power to the charging unit, down to the gauge. There's the 5-to-1 prescaler, which takes high voltage and reduces it to low voltage, and it communicates with the state of charge meter, which is like our battery or our fuel gauge, if you will. So here we've got the rear box, which is expanded in the next diagram, the front box, and they each have a high voltage fuse, 600 amps, 150 volts, because our system is running at 144. And then the 12-volt battery vehicle, so that's just our regular Optima or whatever else you have. I might do an Optima so we can get away from traditional flooded lead acid. TBD, because that's going to sit in the original spot up in the front. And then there's a couple of relay switches, the SHUNT, which is a very important unit. You can see so many of these wires all kind of converge here to the SHUNT, to these big fuses. There's our 12-volt contactor, which heads over to the DC-DC converter, but then there's another 48-volt contactor. That's our big boy, which will run directly to the main switch. So let's go to the complicated diagram that David has made. And I've taken their 2+3 configuration, I made it the 3+4. There's a few questions I have, so just up front, before you start using this as your own, I want to let you know that I'm kind of learning as I go along here. This is just fun. And right now, Jerry's talking about his CAN bus settings, and he is working on modifying the diagram, the wiring diagram that he made, good CAN, bad CAN, or so I call it CAN do and CAN don't. So those are going to be settings I'll have to work with later, because right now we're trying to do the stuff that's like pre-wired and pre-labeled. All of these terminals are set up. There's a few modules I have that will be communicating via CAN. I don't know what they are exactly right now. I know that the BMS sure has CAN, and one of our chargers, I think our second car is a CAN. And there's like a special thing from Thunderstruck that I got to disable the CAN or to sort of compensate for the CAN, whatever it was. But on our first car, we're going to try to avoid CAN bus if possible. I hope that's possible, because this whole kit, I think has that set up that way. Okay, so we've got, starting here, 1, 2, 3. I reworked all the wiring here. It's a little bit backwards so that we actually end up with the correct positive and negative to match this diagram, our Bible. And starting with that, the positive there's the main switch, which comes from the contactor and sort of the main EV stuff, and then it goes into the battery. That switch is going to be mounted on the side of the battery, and that is going to send power going into front box. It will be attached to the positive, and then it goes in series, a series connection from positive to negative, to positive to negative, to positive to negative. And that negative is going to come out of the front box, travel through the conduit in the car, underneath the car, however we mount those cables, and it's going to go all the way to the trunk box, into the positive. Positive to negative, to positive to negative, to positive to negative. We have 4 batteries here. This is all in series. It's called a 1P7S, which is 1 parallel 7 series. Each of our battery modules has 6 cells of 74 parallel wired batteries. You know, voltage and amperage increases when you wire in parallel. Whereas I think it's just voltage increases when you wire in series. Think of it like water, electricity. Sometimes it really helps to think of it that way, because if we wanted to add more power, we would wire like 2 sets of 5 batteries in parallel, and adding the way that the diagrams are set up. Let's see, maybe we can just do that. You know, here's a series here in our BMS manual, there's a series diagram. So it's going to go in one way and out the other way. Everything's wired in a straight line. If you have parallel, you have in splitting and going into 2. So you're kind of like increasing the potential for flow here, because you have 2 channels of power at the same time as versus just one. You know, that would be the series. This is parallel. This is also called series parallel because it's got series mounted cells here and parallel mounted packs. I hope I'm explaining that right, because sometimes I get a little lost in it all myself. So each of the cells within our Tesla module are wired in parallel, but it's in 6 clusters. Each of the batteries, a battery is a series of cells technically. So a 12-volt car battery is 6 cells, each are 2 volts, etc. And so this one has 6 units of 74 pieces each. Okay. Our total system is running 42 cells. We are wired so that LTC 1 corresponds with battery module 1. I had to go through a couple versions before I figured that out, so that's important. And then what else we have here are thermistors. Thermistors are essentially measuring the, I think, temperature of the battery packs. And the rest of the wiring here for LTCs, which are Linear Technologies battery monitor chips. These are what help the charger make sure that everything is charging evenly. I've gone through the diagrams. I've started to highlight relevant information, things that I can reference quickly. That's one of the advantages to having it on the computer here. So we have a total of 4 LTCs. The battery module, or the battery monitoring system, the BMS exists as a main controller and then a satellite on the side. I'll show you that in a minute. How cool is that Humvee, huh? And if I have this correct, I think we're looking at LTC 1, 2, 3, 4. We have 2 packs, which will be like front pack, rear pack, and then groups. I'm not sure on groups, and I'm not positive on cells because there might be a couple gaps, but I believe that's what it is. So the charger here, essentially on the software, it's going to look like this. It'll give us all of our cell information. We have 42 total, which is 6 from each battery pack. You know, 6 in each one of these times 7, 42 cells total. And it will watch the voltage of all of these as they charge and discharge and feed relevant information to the charger and to the display on the instrumentation. When you splay out all of these wires, it gets a little messy. Looks kind of like this. 15 minutes of tidying them up and you can have them all look like this. And the important thing to remember is that at the end of all of this wiring, the negative should go into the shunt, because the shunt needs negative to negative across it so that it can measure an accurate voltage reading and give that information to the rest of the system. Now, let's have a look at all of this stuff here. All of this wiring here is just Amazon purchase, but it's hard to find correct wiring because they want to sell you like copper plated tin wiring or aluminum wiring or aluminum plated copper or tin plated copper and all these different versions, but we just want some solid copper wiring. This isn't out in the Arctic. It's not exposed to weather. It's going to be inside of a car, and cars use solid copper wire. So when you do your shopping for wiring, just be sure what you're getting is real copper. Oxygen-free copper, 99.9%. Let's go. Some of our wiring stuff here. The J1772 communicates with the AVC2. Got some wires for it here. A lot of these diagrams that aren't available when you purchase the unit like this little guy of these, you can get through EV West directly, which helps a lot. All right, the first thing I want to start with is my new best friend in this whole project, and that's going to be the wire label machine, because we need to know that we are labeling everything, because all we have is a ton of orange wires. We know that those are 400 volts, and I don't want to be constantly tracing them back to the source. My goal with this whole build is to create something that anybody can pop open the lid and know exactly where wires are and what's labeled, and make it very easy for service in the future. Because while it's supposed to be very reliable, and the simplicity of an EV system ideally gives you a better service life than like an internal combustion engine, since there's fewer moving parts, we still want to know what all of our connections are like, and I want to make them professional. I want to make them clearly labeled, and I'm going to have a nice diagram either stuck on each box, or I'll have a diagram printed and laminated so that the owner of the car can know exactly what they're getting into and where to look if a fuse should pop or a connection should corrode, things like that. Having, wiring kind of like this, where it's loosely placed and having issues of it being exposed to the elements and potentially breaking. So our contactor box is where a lot of the things will finish. I wanted to show you the fuses here. They're going to go inside of this little failer. It pushes in, they click into place. That guy snaps onto our DIN rail. The DIN rails that I bought on Amazon are a foot long, so I'll trim them down. They're aluminum, and once it clicks on, you can slide them to arrange the position. There's a few other things that you can attach to the DIN rails, but it looks like they're just going to sit here in the contactor box. These are the heavy fuses that are going to go to the individual battery boxes. The batteries themselves, I bought these. They're beautiful. Look at that mirror polish. EV West started selling these so that you don't have to bend your own out of copper plate. They are copper, but I think they're nickel plated. And I ordered 28 of them because we have 7 batteries and 2 cars, with each battery having 2 terminals. Gorgeous things, but that'll keep the wiring so we don't have to make those ourselves now that they're available, $9 a pop. The gland nuts that are going to go in and out of things and house the 2-aught wire, they have this nice cinch soft hose end here, so as you tighten down that final end when you get the wiring in, it should make the wire as snug as a bug in a rug. It won't budge, and it won't have any sort of going in and out friction. And then this is the side that's going to attach to the surfaces like that. So we'll be hole punching a couple of wires here and there. This is our BMS satellite. You see it's got a little bit of it's got connections there. The sides here are for the thermistors. We've got 5 and 5, each with 2 wires. We have the front connections here for our LTCs. Those will monitor the batteries. And here's the BMS controller. It's almost identical, but it's got a processing board. It's got a connection here to the headphone jack. On the other side is a USB cable. And that's how we communicate to our computer and our software. Here's the wiring for all the LTCs and the battery cells. It's going to go right into the circuit boards that are attached to the side of the batteries, which EV West installs and sells the batteries with or without those boards attached. Here's our thermistor wire. So there's the 10 wires there. Again, this switch is going to go on the side of the battery box. The holes are already cut out for it. EV West has HOV stickers, and they also have high voltage stickers. So I went ahead and picked up a set of those. And I'm going to just start labeling the wiring, the terminal ends, what goes where. And this is our 5-to-1 pre-scaler. We have the plug now. I ordered that as well for the Prius cable with the terminal ends. So we can crimp our wires and click them into the connector, run those all the way into our controller. The controller wiring is here. The controller is downstairs. This is the DC to DC. So this is the big positive. Because it's red, I think that's the 12 volts to the car battery, the original lead acid battery. And I think this is the high voltage on-off stuff. And then this is a signal wire. So really nice. It's got these cooling vanes, but this one has cooling vanes with a fan. So we're really going to put this somewhere where it's not going to be just sitting in a compartment and getting hot. So it's probably going to go exposed somewhere in the trunk, not so much in the engine bay. I say trunk because here's the cable for it. So this is one way you can charge your car. The second way to charge the car is plug in the J1772. This is our tachometer interface. This is going to communicate to the gauge with a little bit of magic, and it looks like it's got CAN bus because you see a braided or twisted wire pair here. Twisted wire pair like this is what's going to be communicating between front and rear box as well. to get our BMS the information it needs. I think we figured this all very slowly. I'm gonna send this diagram off to be approved, and then I can start wiring the batteries in the battery boxes, get all of the extra bits and bobs inside of each one, and then create a final diagram for my battery boxes. So we're creating a harness, but for the most part, it's here and it's figured out for us, and the customer service helps me figure out the rest. Well, I'll tell you what, I'm having so much fun wiring these little guys up. Now, you want to be careful that you don't plug these in to the BMS like this once they're hooked up to the batteries. Before we use a tester, we're going to use a tester to make sure that all of these circuits are wired correctly, because we're essentially linking this to this. Ba-boom. And the battery voltage will be active from the batteries once we hook it up to this BMS interface board. This board right here is installed by EV West. Their logo is on it, and the voltage for each cell is measured. They tested it, and they checked the connections of each cell at the top, because there's a few spots where solder could break on those little terminal ends, the little lithium cells. So once we wire all these up, we'll test it before we hook it up to the brain. Getting set up for the wiring has actually taken quite a bit of time, because I have to order a lot of different wiring harnesses or spools of wire. Purchased a bit of stuff here. We've got split loom, we've got the braided looms. These are pretty good because they expand, but they also have a style that you can open up in the middle like a split loom. I don't really like these because I think they look kind of corny, but I might have a use for that after all, because the price is really cheap for these. These are a little bit more expensive, but much better. And then we've got just spools of wiring. I think this is 20 gauge maybe, or 18 and 20 are like the common sizes for a lot of the smaller communication wires. This is 10 gauge, it's the hefty stuff. This will be things like the charger. So it's a lot, because I'm doing a little bit of work on the heater, I'm doing a little bit of work on the PCB, I think that's what it's called, boards, and I'm doing a little bit of work on the battery boxes and the main diagram here. And some stuff's in shipping, some stuff is still at EV West, so it's like a lot of back and forth. It's a big project though, but I think I'm getting a handle of it. Each battery box is going to come with one of these here, and this is the connector. You can see the 2 screw holes there, and this unit in the wall, it's got another 2 screw holes there, 4 male, 4 female, and I believe these guys are being used to communicate the signal from the BMS between the 2 boxes, which is accounting for 2 of the wires, so we'll figure out what the other 2 are used for. These paper boards that are in here that we discussed a little bit earlier, they're thick, a little too thick, and I want to get some mica boards. Those are the fiber boards that are used, MICA, the same stuff that's used as like a wave regulator or scrambler or something, I forget the term, inside of your microwave. There's that paper board on the side. Sometimes your microwave will start sparking, and then that paper board will be the culprit. So if you have sparks in the microwave for no sure reason, check the back side of that paper. And here we'll put those along the side. And the reason I bring up microwaves is because that's the most available product, and they are going to be a little small. So we'll end up kind of packing them around the edges. A few components are going to start piling in. You only need 1 kill switch. Our battery kill switch is going to live here, but it's not gonna live here because we only need 1 switch, and it's gonna be closer to the contactor box and all the main power distribution of the front. So this will be wherever that box will lie, and then the contactor box, wherever that ends up being as well, is going to cut the power to the back box as well as the front box. So it's the first thing going in to as you look at the flow of electricity, it's the first thing, this big breaker. And I think it makes more sense to the driver and anybody servicing this vehicle in the future to open the hood to disconnect the power, rather than going and looking inside the trunk behind a panel that is going to be our decorative panel, which covers our rear box. So that's coming later. This hole will just have to be plugged up with a machine piece of aluminum and some screws. I'll probably just get a little bit of a rectangle in there. It doesn't need to be pretty because, as I just mentioned, we're gonna have this whole back covered with a decorative carpeted panel. And I'll be sure to match the carpet style of the original panels, which is just this black, very 70s looking weave. Now it's time to wire up the satellite to our LTCs, and that's going to connect to the harness on the battery, which is, voila, one of these. This is module 4. I'll make sure I got module 4 here. Cool. So from this guy, there are 2 pairs of wires that are both purple and pink. Those should be our thermistor. Look at the note on the diagram that EB West has on their website, the Model S Tesla battery PCB and BMS board revisions ABC. I believe this is our tester board, and this is the board that's right here on the battery. They've already wired that in, saves you like $50. For $50, saves you a lot of wiring and some potential for damaging the cells, etc. And actually right here you can see a repaired cell, which is always interesting the way sometimes they just move it to the side and resolder it. Okay, note, thermistor note. Tesla has changed the pin positions for the battery thermistors. It's important to use an ohm meter to find the proper 2 wires for each thermistor. To find a match pair, use the ohm meter between 5 and 10,000 ohms, and it's a valid output for the thermistor. These pairs might be pink-pink or pink-purple. Okay, so we got 4 wires. We'll just, as we're staring at our diagram, we've got number 1 on the top right, 2, 3, 4. So it looks like 1, 2, 3, 4 are the thermistor wires. And then on the bottom is 5 through 12. And those are all gonna be, I believe, the cells on the board itself. Let's see. 1, 2, 3, 4 thermistor, cells, yeah. That's cell 6, 4, 2, 1, 1, 3, 5. Remember, there's a negative there because while we have 12 cells that can be monitored through the LTC, the 13th wire is to complete that series circuit as the negative. And that means that C minus, black terminal 8, will not be used on module 5. Here. So essentially we're linking these 2 modules through one harness. This harness. Looks like it's purple and purple for this one. That means pink and pink should be another thermistor. Yes, very nice. Solder that I replaced was these 4 up here, those big boys, these 3 here, and a couple of small ones that look questionable. If your garage door opens and closes and the season's changing stops it from opening and closing fully, or like once the motor and the units all warm up, it just sort of freezes halfway up or halfway down, or gives you the 4 flashes, or I should say, and gives you the 4 flashes, which says the load resistance warning. You probably have an intermittent fault somewhere. And the capacitor here is actually what's causing the capacitor is responsible for just the starting operation of the motor because it's a 1/2 horsepower motor and most of the work should be done through the spring up there. And these are the switches up. 1, 2, 3, 4. Yeah, still broken. Dang it. It was good while it lasted. polyamide tape. Ooh la la. It was bugging me that these plastic caps sometimes want to come up, so I'm gonna just secure them with some tape.
If you're worried and you can't sleep, and you fall asleep.
Looks like we have a little remnant of old grease on here, but that shouldn't be a problem. EV West carries this, and it is copper paste. It's specifically formulated as an anti-seize and very conductive. So we're gonna install this, and I think it's just the first. A light coat on the threads, and once we clean up the old goop here, one critical step so it doesn't put me in critical condition later until it's time to install. One more consideration to make, you know that this box is going to be real tight in there, so any sort of service will need to be done with the box slid out. And you may not have to remove it all the way, but it's gonna be pretty close. Ideally, you want to keep it on this bottom ledge here. That's like the third motorcade today, you guys. Chill. We know that our positive terminal is going to be on the right, which means it's going to be on the bottom of each of these, and we can have our cables route in through here. I think that's what they have this hole for, or we end up using this here. But with that cable routing, we want enough slack so that the box has enough room to move in and out, which means that as the cable comes out of the box, it'll have to make its way down here to the filler neck hole, and we'll have to seal that up as well. The use of taxpayer dollars every time they need to get you to a meeting. So, okay, so the thinking is to have enough working cable there, and of course it's behind a cover so we don't see it, but we want flex. And if we put terminal 4 there, we'll have to reroute a cable to the plus and then go minus plus into the like diagonal this way. If we do 4 here and 7 there, then we can just have it in this corner and then diagonals going that way, which I think finishes up here and gives us a direct in and out, much cleaner install, I think. So that's probably what I'm gonna do, is put 4 on this side. It's really tight in here. I'm breaking a sweat moving all these boxes in and out. It's really tight in that box, and the battery module is 55 pounds a piece. I have to bend over quite a bit and get them from forward. That's why you gotta stay in shape if you're gonna do this sort of thing. So I gotta remove some of the thicker insulation and opt for thinner insulation because it's too thick and I need a little bit of wiggle room to get that 4th box to fit. It's just, I'm glad that the second shipment of mica paper showed up today, because this white stuff here, it's like 1.5 millimeters. It's too thick. I'm going to position you here, and I'm going to see how much these batteries relax. Clamping them was the right way to get it to fit inside that box. Start with the outsides and make your way to the middle. Also, putting a clamp on here really helps because I can wiggle this entire battery just by grabbing onto the aluminum outside. The bottom is where the eyelet holes are. This top didn't have any, so some vice grips into the soft aluminum. It's a little marred, but I think it'll survive. It's tricky to get it to sit inside of the channels. I had to kind of lift against the end, which is right butting up against the wall, and that's where the clamp came in handy, and then try to get it to fit in this side first and then drop the back. 220 pounds of batteries, a box that weighs 46 pounds with one plastic, and then I gotta weigh the second plastic and the lid.